exponential growth and decay problems follow a formula that is your answer is p parentheses 1 plus or minus r raised to the t. And sometimes the variables change, but these are the ones we're going to go with, where p stands for your principal, or the starting value. R stands for your rate. I don't know why that didn't fill in. R stands for the rate, and that's your percentage. You can get that by doing your percentage divided by 100. Talk more about that in a minute. And T stands for time. The plus or minus between 1 and R is because we have two different types. We have growth and decay. If it's growth, it's going to be 1 plus your rate. If it's going to be decay, it's 1 minus your rate. So let's look at the first example. Bill invests 500, so that's your principal, it's your starting value, into an account with an interest rate of 3% compounded annually. Now, compounded annually just means once a year, and so it's a basic exponential problem like we're talking about. Compounded interest, it can be monthly, quarterly. We'll talk more about that in the next video. But because it's in an account that gains interest, this is exponential growth, and the rate is 3%, but we're going to change that to a decimal for rate, and we're talking about a term of 4 years. So our answer is your principal, starting value, 1 plus R. Now, R is your rate, and you get it from your percentage divided by 100. The percentage is 3, divided by 100 is 0.03, raised to the amount of time we're talking about is 4 years. And so I want to simplify my parentheses a little bit. 1 plus 0.03 is 1.03, and I'm going to raise that to the 4th power. At this point, I'm going to let my calculator do the work for me, where first I'm going to raise to the exponent, 1.03 raised to the 4th, and then times the principal last. We always times the principal last. And so we have 1.03 raised to the 4th power, and if I hit enter, we're getting 1.1255. And then times the principal is the last thing you do, times 500, we get 562.75. So 562.75. And notice that because it's money, I round it to the nearest hundredth. Population of lions is declining 8.2% a year. The fact that we know it's declining means we have exponential decay here, so we're going to use 1 minus the rate. In 2012, the population is 7,000. It's going to be our principal. What's the population in 2017? So we have to think about, all right, our time is years from 2012 to 2017 is 5 years. So our problem is going to look like A equals our principal, our starting value of 7,000, 1 minus 8.2% is the percentage. The rate is that divided by 100 is 0.082 raised to the 5 years. You can simplify what's in the parentheses. 1 minus 0.082 is 0.918, and that's going to be raised to the 5th. Let me move my calculator over a little bit, and I'm going to type this in. First, I want to confirm that I'm right about my subtraction. 1 minus 0.082. It is 0.918. Okay, so let's raise that to the 5th power for 5 years. And then the last thing we do is times the starting value, 7,000, and we get an answer of 4,563.64, but we can't really have 0.6 of a lion, so we kind of just cut the decimal off there, and we'll just say 4,563. 4,563 lions.